audible, sir.
Yeah. Okay, fine. So in this session, so what we will do is, so mostly we'll have these kind of sessions every week or so. So around the same time, 6 to 7. So the sessions, why we have these sessions, especially is to connect actually the programming part of the machine learning to the course. So it's not, of course, they are not graded, or you won't have any graded assignments or like say an exam from this, but hopefully what is this is like you will try to understand how to implement these machine learning algorithms using Python. So, and then use it in various other applications or projects, which we will also discuss about few projects here and there moving forward after we complete these sessions, which you can try, and might be we just try we'll discuss with the team and then try to like say give them. So in this session, what we are going to do is, so first before that, so how are you people familiar with Python? So anyone have like say have used Python before, or like say anything like that? So or any is anyone new to Python, or like can I just have a quick response about that? Hopefully I'm audible. You can speak out because it's just an interactive session. So yeah. Yes, so the programming sessions are starting today. So this is the first session which we are conducting on behalf of the programming. So there weren't any other sessions which are relevant to programming, but there were, I think, so assignment discussions sessions which were before by other TAs. Yeah, so like yeah, so these sessions will happen every Monday, weekly in the same time. So this is the schedule. So yeah, we'll be coding all the like say ML. Yes, yes, Rohini. Yeah, speak out. I think so. You are able to unmute, right? I just don't know why still. Oh, yeah, I can now. Yeah, okay. So I'll just share the screen. So yeah, let me also give the chat section here or here, so that so if you have any doubts, please do talk out so that we can just. So yeah, so I think so. I'm audible, right? Still. So and you can see my screen, right? If I'm not wrong.
Yes.
Yes, sir.
Yeah. So are you people familiar with Python, or shall we go from the basics of like say how we like say convert things and convert the math into Python, or little bit of say I'll just. So is that fine, right? So shall I just
Yeah,
give?
fine, fine.
Yeah, fine. Okay. So this is
So
actually,
we'll
yeah.
just discuss like how we convert the max into Python.
Yeah,
That will
yeah.
be.
So that's what our aim is. So the aim is actually how we convert math into Python and what we are going to do here. So this is actually called, hopefully everyone knows this, Google Colab, so Jupyter notebook, where we can actually write our code in each cells and then run it individually rather than a file. So this is more easy to present. So that's what we are using. That's what we'll be using to actually like say code things, and then we will share you this Colab files to you through mail. So that will be fine. So why we use Python is actually like majority of the people here actually start to use Python because it's very easy to understand, and the learning curve to convert the math part to Python is also very easy and very straightforward. So that's why we try to code in Python. No other reason. So there are many other languages out there to try out, but for the easy understanding and learning, we use Python. So first things in Python. So first, if I wanted to actually say print some like say any like word. So in some sense we use print. It's as simple as that. So we just print hello world, and when we run this cell, so hopefully it connects. It connects to the cloud. So what happens is here it will connect to a server from somewhere in Google, and then it'll actually run things, and we can see the output. So this is a very basic, say hello world program. So now what we can do next is, so first we will try to actually say in the first part of the lectures, we saw that there were vectors, right? So there were some vectors like say which we will plot or something like that. We will here in Python, what we'll do is instead of vectors, we'll call them as arrays or here lists in some sense. So I have a list L and or B vector. In here we will actually what we'll do is we'll try to feed the numbers here and do our processing. So this is a very basic way of initializing a list. So in some sense, this is considered as a vector in our say in the programming language. So we use Python list, but rather than Python list, what we will now we are going to introduce is we will use a module called NumPy. So what is NumPy? So I'll just write it. So sorry. So NumPy. So what is this? Is so import is something which actually so we will import. There's a module called NumPy in the again you say it's there inside this collab, and we are importing it. So this NumPy, what it does is it will actually perform all the calculations we wanted to do. So for example, we wanted to say find dot product. So instead of actually writing a code for a dot product, we can try to like say initialize an array. So array is again a very like say straightforward term instead of a vector. So we have a vector v equal to 1, 2, 3. What we can do is we can have array equals to numpy dot array of say v. And then if I just print array, I'll get the numpy. Just a minute. Okay, so I didn't run this. So yeah. So here I get 1, 2, 3. So 1, 2, 3 is the vector, some sense here in the mathematical term, but in the programming side, we will call it as array. So with here, there are so many operations in NumPy. So that's what we are going to like say, try to understand them. So maybe what we will do is first we will actually try to do a simple, like say addition of vectors. So for example, I'll initialize a vector of, so NumPy dot array of say I'll do 1, 2, 3 and v2 equals to numpy dot array of yeah, so 4, 5, 6. So now if I wanted to add these two vectors, we just like say add it, right? So it's very straightforward in NumPy 2. So what we will do is we just add v1 plus v2 and we get the result, some sense. So you can actually try to subtract the vectors. So v1 minus v2 is again there. So again, we have multiplication of vectors. So v1 star v2 and also like say v1 by v2. But when dividing, we should ensure that there are no zeros here, because if zeros in v2 exist, then we'll get a zero error where we can't divide an element. So what these are doing is here multiplication. It's actually doing element wise multiplication. You see there's no vector multiplication, but it's an element wise multiplication. So you people get it, right? Some sense. So now for dot product. So what we can do is for for dot product, what we'll do is numpy dot of v1 comma v2. So what is the expected output you think? What will be the answer for dot? Like say if we do dot product of v1 and v2, anyone? Like you can type in the chat or you can actually unmute yourself and answer. Anything should be fine. Yeah, anyone? So what is the dot product we have to give? So what we will usually get is this. So I'll just share a different slide. I think so it's visible, right?
Yes, sir.
Yeah. So we had an array of, so v1 equals to what we had?
1, 2, 3.
Yeah. So 1, 2, 3. And then v2 equals, we had 4, 5, 6. So when we do a dot product, what we will do, so we will be v1 transpose v2, right? So that's our dot product, right? Or like in some sense, this is a column vector. So when we always treat it as a column vector. So what
32.
yeah. So it's so exactly right. So we just v1 dot, I just write dot, which is equals to 1 into 4 plus, or 2 into 5 plus 3 into 6. So which is equals to 4 plus 10 plus 18, which is equals to 32. Right? So this is what our expected answer is to, and we should probably get this here, right? So basically what this dot does is they have already written a code for how to write the what dot product say to take. So what will NumPy do is if we just call this say dot dot, it'll automatically do the dot product. So instead of dot dot, what we can use is we can use this symbol actually to find the dot product, which is very like say it's the same instead of numpy dot dot, as it's very big, so it's an as we will use dot product. Yeah, it's right, Saidhan, it's 32. So instead of using dot dot, we will use at. So at symbol to actually compute the dot product. So now let me just go through this collab, which I have framed especially for our tutorial. So first what we will do is we'll first start to import the NumPy module as NP. So NP is like just a short form for NumPy, which I'm giving here. So nothing, and instead of NumPy.array, I'll give NP.array, nothing else. So now what I'm doing is array equals to, I'm defining as NP.array of 1, 2, 3, 4 and 0 array. So this is now a function. So what this function does is it will take my size 3, c. So 3, 3, imagine it's a 3 cross 3, matrix, and it creates a 0 array, 0 matrix of 3 cross 3. So you can give any size you want, really. So it doesn't matter. We have something like zeros, we have something like ones, we'll try all things. And zeros is something like it'll give us full, instead of trying to put 0, 0, 0 everywhere. What we can do is if I just give this, I'll give a 3, I'll get 3 cross 3 matrix. So if I give array, so it's just normal array of instead of like in Jupyter Notebook, what we can do is instead of print, we can just give the value in a cell and it will automatically give us an output. So it is just customization. And if you see here, it gives a 3 cross 3 by the way, matrix. So if I just give 3, 6, so what will be the expected output? So 3 cross 6 matrix. So it is if everyone have gives it. So this is what. So 3 rows and 6 columns. So is everyone fine with this?
So 3 rows, 6 columns with all the entries are zeros.
Exactly.
Okay, sir.
So in the same way, if I can define one array equals to np dot ones of maybe say it's I'll just give 7, 8 some sense. And if I just give one array, I'll give 7 cross 8 matrix with all entries 1 some sense. So zeros and ones we will commonly use it because in our code. So you will understand where we will use it. But this is also another stuff. And we'll just check out what is np. There is another function called np.i. So I'll just say you so mat equals to np.i of 3. So now what do you think the output will be? Any guesses? I mean, so we just see it, we get a 3 cross 3 identity matrix. So we can define an identity matrix with the function I here. So if I just increase the number to 5, I'll just get a 5 cross 5 identity matrix. So these are very easy. Like instead of trying to do it manually, we can actually do this some sense. So or what we will usually do is we can actually do something like this. We can we have to first initialize a list, and then we use something called a for loop. So for I in range of 5 maybe, and then I'll have dummy equals to empty list. So for j in range of 5. Dummy. I'll just say you how it works. Append of 0. Sorry. P1 dot append of dummy. Yeah. So I think it should. So this also does this is also what I'm doing is I'm actually first going the range of 5 and I'm creating an empty array basically, and then I'm appending zeros in every other, like say, so this is one row, this is for columns, this is for rows literally. So I'm appending in every row and I'm appending it 5 times literally. So this is actually creating a 5 cross 5 matrix with just entry zeros. But instead of this one, I can directly say give something like this and then create the matrix. And let me go to linspace. So linspace is again a very interesting idea. So what we'll do is say I have some x array equals to np dot linspace of 0, 10, 5. I'll just give this. And if I just give x, what happens is, so what do you think is happening really? So any idea what's happening here? So you can also chat and try to unmute yourself to answer the questions. So what's happening here? So it's trying to actually divide this. So what is happening is we have a 0 to 10, like say range, and it is dividing the 0 to 10 into 5 parts literally. So starting from 0, 2.5, 5, 7.5, 10. So this will be easy to actually like say give a x range, right? In x axis. So we usually have in our x axis 0, 1, 2, 3, 4, right? So instead of 0 to 5, if I give 1, I'll just give 0, 1. Okay, not sorry, 1. I have to give 10. Then I'll give or I'll just give 9. So I'll get 0, 1.25, 2.5, 3.75, 5. So everything has it. Or I'll give 11. So this actually will give me 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because it has 11 splits, some sense. Do you get that, everyone? What is the use of linspace?
Yes, sir.
Yeah. So now we'll just go and see what are the data types. So array.data type, we know it's like what it will do is this array, it is checking what data types are inside this array. So in this case, it's having int 64. So 64-bit integer here. So if I just try to like say, maybe I'll just define an R1 equals to np dot array of 1.5, 6.7, 8.9. And if I just try to give R1 dot d type, it should give float 64 as its floating point. Now this shape. So shape, what it does is it gives us the dimension of the array. So suppose if it's an array, it'll just give us 1 value. If it's a matrix, it'll give us 2 value, some sense. So for example, here here we have an array which is of course just 4 numbers are there, right? So its dimension is 4. If suppose I just give dimension of mat instead. So yeah, so if I just give mat dot shape, so it should probably give us 5 cross 5, right? Because we have defined a 5 cross, or I'll just give one array which is 7 cross 8, right? So we have defined it. So I'm getting 7 cross 8. So it gives us dimension really. And what we can actually do with this shape is, so now as I have 4, I can change into 2 cross 2 matrix. So it actually takes 1, 2, first 2 as one row and 3, 4 as the second row. And actually, and what is the main point is it should be compatible. So here in some sense 2 cross 2 is actually equal to 4. So in some sense, that should be compatible. If suppose that is there, I can reshape this. So 1, 2, 3, 4. Even one array, I can actually reshape into, so if suppose here I know it is 7 cross 8, so it's 56. So I can change it to 28 cross 2 maybe. So if I just do it, I'm getting 28 cross 2. So because 7 cross 8 is also 56, 28 cross 2 is also 56. So that in that sense, it's compatible. Sir, what are the parameters of the lint space? Okay, so parameters of the lint space is actually it's the starting value, ending value, and how many splits. So it's just, I'll just write it here. Start value, end value, and number of splits. Fine. So these are the parameters of lint space. Right? So this is the reshape. So this will also come in hand when we actually try to implement an algorithm. So we'll just first get into basics, like, little bit of basics. And what I can do is I can do indexing. So if I just wanted to, like, say, get the 0th element, first element of the 0th element. First, so always arrays have an index between 0, 1, 2. It's not like one is the first index. We call it as a 0th index. And then first index, then second index. Something like that. So what will this print of array of 0, 1 will fetch? So any idea? So basically, I'll just go here and write here. So it'll I have an array of 1, 2, 3, and then 4, 5, 6. So here I just see this 0 is there, right? So this 0 is actually my 0th index. So this is 1, this is 2, and this is 1, this is 2. So what will be my, here I have 0, 1. So what is my 0, 1? So this is row and this is column. Yeah, 2, right? So if I just try to and leave this for now, 2, right? So now what this is doing is, so this is actually giving me all the in the first index, but all the rows. So if I just print this out, I'll just able to show you. So that is this part, some sense. So it is actually giving me everything from the row, but only first part in the column, really. Some sense. So this is actually like it's the rule to write. It's saying I have to, like, say, print every in each and every row, print only the first column, whatever the elements in the first column. We understand? If I just now just change this to not 5 but 2, what will be the answer? Yeah, correct. 3, 6. So everyone get this, right? Is anyone having any doubt? Okay, I think so. No. So yeah. So now we'll just try to, like, say, have a little bit complicated example where what we are asking here is, I am defining an array of 1, 2, 3, 4, and I'm trying to print the array greater than 2. So what does this mean is, it's not actually array greater than 2, but what does it mean is, it is actually the, it should get the indices of the elements which are actually greater than 2. So if I just now print are greater than 2, what I will get is an array which have the indices greater than 2. So for, if suppose the our elements are greater than 2, I'll get a true, else I'll get a false. So these elements should only get printed. So this is called fancy indexing. So I'm getting only 3, 4. So the indices which are actually having elements greater than 2 are only getting printed. So everyone get this, right? So if I just have greater than equal to 2, so what do you think will be the answer? 2, 3, 4. Perfect, right? So this is the very basic idea of NumPy arrays. Now we will actually jump into a little bit of like say how we use these NumPy arrays in probability quickly, and then we will see one or other algorithm today. Like hopefully we will be able to cover linear regression today. So before that, I'll just try to like say like give you an idea about how we work with probability. So now as probability involves in randomness, so if suppose I have np.random.rand of 5, now what I'll get is it'll fetch me just 5 random numbers in an array with actually it will actually give me a uniform distribution of 0 to 1. So these are all like say numbers between 0 to 1, uniform distribution of 0 to 1, and it will give me 5 elements. Suppose if I just give 7, it will give me 7 elements. This rand actually give me random integers between 0 to 1. So everyone gets it, right? So now let's simulate these probabilities. Suppose flips equals to, so can anyone explain what I'm trying to do here? So there is an array 1, 2, 3, 4, 5, 6, and there is size equal to 100. So size equal to 100 in some sense, our whatever this flips is, this has 100 elements in it. And it just says that np.random.choice of this array. Really. So first let me actually try to give what this np.random.choice of right 6. So yeah, picking a random number and printing it. Exactly. So it'll pick a random number from this array and then give it. So here every time basically it just changes. So if I just print the flips, yeah, chooses 100 elements from the given cells randomly. Exactly. That's what is happening. So in some sense, can we say that this is actually the point where we actually roll 100 dice and get the output? Is it actually equal to that? So rolling 100 dice and getting the output is actually equivalent to this, right? In our program. Is it right? Can I just say that?
Yes, sir.
Yeah. So this is how we simulate things. So what we do is we actually, if we wanted to say, like say, do the same experiment with the toss. So what will I do? This is for dice. So if suppose I wanted to like say implement the same experiment for a toss. So toss equals to leave this. Do not. So any idea on what to do? So np dot. Of course, this is just giving me the answer, but still. So I can give, yeah, 0, 1, size equal to 100, exactly. So size equals to 100. And if I just give toss, just gives the toss with this. So it's all, of course, equal probability. So there is no, like say, bias or something. It just gives, yeah, exactly. If I wanted to just give H or T2, I can just give H, comma. So it just gives me full of H or T, right? So this is a very, like say, very basic way to how to, like say, give a toss program. And yeah, so again, I'll just introduce you to basic things. Again, this is so what we can do is we can actually define something called a function. So what we'll do is instead of like say giving these as like each and every time we wanted to run something, what we will do is we'll try to encapsulate into a function, and then we will only call the functions. So what we'll do is we'll just, it's the same straightforward way of doing actually calling a function. So here what we will do, so in some sense, just a minute, yeah. So here what we will do is, some sense, we will actually try to write f of x, right? So f of x equals to some, like say, like x square plus 5, right? So this we call f as a function, right? Here what we will do is this x is the parameters and we will do something with the parameters. It can be anything literally. It need not to be only quadratic or something. We can do something with that parameters, maybe update it. We will try to increase it, decrease it. We will try to add it. We can take any number of parameters and then try to do something and then return it. It's as same as the function which we use in mathematics, right? So of course this won't really give anything. So now suppose consider an example, like say, I think so this was one of the questions in week 1, if I'm not wrong. So consider an experiment of rolling at 7 dice. So we can actually try to use Python and, give the answer. So this is a very very straightforward. It's just 6 power 7. That's it. So total number of outcomes of rolling a 7 dice in some sense. But now this is a question on say what we want to do is with continuous, what is the probability of getting at least 2 even numbers? So here what we can do is we can define a function in some sense. So def roll 7 dice where we have to return np.random.size is equal to 7. So this actually simulates our 7 die roll and at least 2 even. So here what I'm doing is I'm counting the number of even using the fancy index. So in np.sum of dice rolls modulus 2 equal to 0. So I think so you have seen this. It's very similar to this something. Array greater than 2. Instead of array greater than 2, what I'm doing is dice rolls modulus 2 equal to 0. So that's what defines even numbers. And then if number of 2 greater than equal to 2, then I return 1, else return 0. So in this sense, what I can do is I can get a P. So the P is how many times actually it is say done. So here basically it is at least 2 even. I think so. P is actually saying if suppose there are more than 2 means it just gives 1, else it just gives 0. So hopefully, of course, it's just every time almost I'm getting 1, but sometimes it will be 0, 2. Doesn't matter. But let's see why is it always getting 1. So what I'm doing is, so now I'm repeating this thing for more than 10 times. So it's not only 1 time or something I have to do. So what I'm doing is I'm trying for 10 times literally. And I see that even after 10 times, it's actually say giving me all the 10 times, it's actually all the numbers are actually greater than 2. But if I just try to increase the number of times I do this, now I see something. Why it's 0.9? Can anyone say this? I think so you have solved the week 1 assignment, if I'm not wrong, but yeah. So this is a very programming way of doing it. So there we actually try to do conditional probability and other stuffs. But with programming too, we can actually try to fetch the same answer. So it seems that only 90% of the times, basically the dice roll was in the 7 dice roll, there were numbers more than 2. So if I just try to increase the iterations, this actually say goes to 0.9396. So was this the answer? Actually, can someone clarify what was the answer for the, I'll just try to go into the course. So I think so this was the course. We'll just check what was the answer for that question. So we see that it's between 0.93 to 94. So even though we do with the conditional probability, we get the same answer. And even we do with this programming way, we actually get almost arrive with the same answer. So it just takes some time. So 0.936, if I'm not wrong. So do you people understand what we did here? Fine, right? Or do anyone have any doubts, basically? A little bit of escalation here where we define functions and this we went through it. So I think so. If anyone has doubt, just again, I'll just repeat it. So it's fine, right? Okay. So there's another question in some sense. So what we are doing here is, so the same question 8 we are trying to solve here. So what we are doing is, it's a cookie jar game where you are a contestant and given the choice of jars. So I think so you have read the question. So in some sense, what we are doing here is, again, the number of simulations it's just given as 10,000 here at initially. So I'm just picking a random cookie jar first, and I'm just picking an initial choice here. And I'm just trying to get the possible reveal. So what might be the possible reveal of the contestant, some sense, and the host reveals something basically from the possible reveals, and I'm trying to get the remaining jar. And if suppose my remaining jar is a cookie jar, I'm incrementing my answer. If not, I'm not say stay wins plus equal to say initial jar. If suppose the contestant switches to the remainder, switch wins will increase, else the stay wins will increase. So we just wanted to find if suppose which probability is higher, switch whether if I switch the probability of winning is higher or if I stay. So that was the question, if I'm not wrong. So whether you should switch or not. So if suppose whichever has a higher probability, that should be done. So yeah. So here if we see that it seems that 66% is there's a winning rate if you switch some sense. So this is also, I think so called I mean, there's a very famous problem, to be honest. So I just reframed the problem and just gave this. So this is a like stuff. Monte Hall problem. So you can just search this problem in internet and you will try to get it. So this is a very famous problem. And let me just quickly go through Matplotlib. I don't know whether I have time for this, but yeah. So there's another module where I can plot some things. So I'll just quickly go through this Matplotlib and we'll just go into linear regression stuff. So what I'm doing here is I can actually plot something. So this figure and this axis. So I just this is of course dummy plot. Nothing is there, but I can actually try to plot this and try to visualize some stuff. For example, here I have 1, 2, 3, 4, and this 1, 4, 6, 9, 16. So this is my X. So this array is my X, first array, and this is my Y. If I just give plt.plot and then plt.show, it actually plots this. So you see, it's kind of an X square. I just 0. Again, let me give -1, -2. Yeah. So again 0 and 1, 4. I just give this. You see, it's actually trying to it's not exact because it's just a line plot, but you see that X square graph, right? Yes. Did someone? Okay, fine. So we can actually customize this by adding some labels too. It's just straightforward. Like we can just give this X label, Y label, and give X axis, Y axis label. And we can actually give a title for the plot, something basic line plot or something like that. So if I just try to, again, this also is possible. We can actually give 2 plots and then show the same 2 plots in the same graph. So 1, 2, 3, 4, 1, 4, 9, 6, it's squared thing. And this is a linear, some sense. So again, we can give a red stuff too. So it doesn't matter. Whatever we want. So, and then what now I'm doing is, so I'm just trying to get a random X in some sense. And I'm trying to find a polynomial. So it's just 6x square plus 2x plus 1 plus some noise. So this is our noise. So usually in machine learning, what class should big class should be it is called Matplotlib. It's a library again. So I've just imported matplotlib.pyplot. So this is our library. And I like NumPy. So it's very similar to NumPy where we use for plotting, right? So here what we will do is, so we actually try to, I am defining a existing function and this is some noise, some sense. So I think so you have learned about noise in linear regression. There will be noise in the data set. So what I'm doing is I'm actually adding an external noise to this data set and then trying to plot something. This is a scatter plot. So you see that there is a, of course, there is not exactly things, but it's still happening. So there's a random numbers, just I'm giving 50 random numbers and trying to plot it some sense. So I just wanted to skip this part for now. I'll just cover this in next class, maybe because of the time constraint. So any doubts till now, some sense. So what I'm doing here is I'm giving some colors, some sense. So colors equal to, again, this is the color which it just gives this is a scale, some sense. So whenever the value is big, the point will be higher, and whenever it's low, the point will be lower. So in some sense, that's the way to do this. And you need not to worry about the C math. It's fine. So even if I take this, I think so I'll just get a grayscale picture. I mean, it's a default thing. Fine. This is fine. Anyone has any doubt till now, or shall we move forward? How to plot it? How to plot if the data is saved as .csv file. So what we can do is, if the data is a CSV file, we need to use another library called pandas, and then we have to do it. So we will cover this in next class. It's fine, right? So we'll cover like these how to do this using .csv file in the next class. Fine. So shall we move forward? Okay, fine. So I'll introduce Janani now. Janani, can you take over and just stop sharing?
Hello.
Yeah.
Okay.
Yeah. So can you? I think so. You can present the screen, right?
Yeah.
Awesome. You can present, right?
Yeah, I'm checking.
Yeah.
Is my screen visible?
Yeah, I think so it's visible. So yeah.
Right?
Yeah.
Okay. So in this session, we would be learning about linear regression, and if time permits, we will cover gradient descent also. So as Sarnath discussed, I think everyone would be familiar with NumPy as well as Matplotlib. So let us run a linear regression model for a toy dataset which I've created here. I'm importing the necessary libraries here. The first one is NumPy, and then it is Matplotlib. And here I'm generating a simple data set. Okay. So in this data set, I'm going to divide this data set into two parts. The first part is going to be the training data, and the second part is going to be the test data in which we are going to test. Okay. So let me check the size and dimension of the train as well as the test. So this is the dimension of the X train and Y train. Second. Okay. So this is the training data, and let's check the dimension of the test data too. So this is X test, comma, X test dot shape, comma, Y test dot shape. This is going to be the dimension. So we have like 40 samples in the training data and 10 samples for the test data. That's how we have split the data set here. Now let us visualize the data set. So if I run this run this cell, I can visualize the training data set here. So the training data set appears to be linear. That's how the data set is created. Now let us try fitting a line which would actually pass through these points such a way such that the error between the points and the line is minimized. So if I plot a line, this is a random line. I'm plotting a line y equals to 3x plus 4. Okay. But it seems like the 3x plus 4 line is not fitting properly. So any suggestion on how this line should be? Should it go up or should it go down? Any suggestion? This red line. So that it perfectly fits the blue points. Any idea? Go down. Okay, so if the line goes down, which means if I decrease it like by 3, what happens? The line is going down. So do you think that the line is perfectly fitting the points now? I've moved the line one step down. So what should we do? Okay, so it's not fitting the points, right? So what should I do? Should I move up or should I move down? So that the points are fitted properly. Up. Okay. So let's try moving it up. So I'm moving it up by maybe say from it was 4 initially. If I move it up by 5, it's moving. Is it proper now? Like, is it fitting properly? Still, it appears like the line is not fitting properly. If I give something like 4.5, I think it should fit. This fits properly, right? So this is like, I actually found a line which perfectly fits this point by trial and error. That is for 30 points, I was able to achieve it by trial and error. But if we are going for a larger data set, this trial and error method won't be working. So we'll go on to a machine learning model known as linear regression. So now let's look on to linear regression. So this is a simple equation for linear regression. H of x is w1 x1 plus w2 x2 plus so on until wd xc. So here w is going to be the weight of the vectors. So if you take a line, say y equals to mx plus b, here the m and the b are going to be the weights associated with that line. And x is going to be the input vector, which is going to have the features. So let's find the weight. So this equation just just says that if we add the products of the weights with the x, then sum it up, we'll get the line which is going to perfectly fit the given points. So if you have went through the lecture, there is a formula for finding the weights. So the formula is going to be x transpose x pseudo inverse x transpose y. So before moving on to this formula, let's check whether it's dimensionally correct. So here the shape of x is, let me print the shape of x and maybe say print dimension of x is going to be x dot shape. So similarly, let me print each and every dimension to make sure that the product is actually valid. So since we are going with the training data here, I'll put x train, y train. Okay. So this is going to be the shape. This is going to be the dimension of x train as well as y train. Okay. So let's check whether the product is actually feasible. So to check that, let's find the dimension of the transpose 2. So it's just a interchangement of rows and columns. So x train transpose is going to be x train dot transpose dot shape. Similarly, for y we needn't require it. So I'm writing it like this. So now if you check, x transpose is going to have the dimension 1, 40, right? I think this commented line is visible, 1, 40. And then this is going to be multiplied with x, which is going to have a dimension of 40, 1. So this results into a matrix, which is going to have a dimension of 1, 1, right? In the second step, what we are doing is that we are taking the inverse. So inverse is going to like interchange the rows and columns. But even if it gets interchanged, here, let's check the dimension of x transpose into y. So x transpose into y is going to be, x transpose is having a dimension of 1, 40. This is going to be multiplied with y, which is going to have a dimension of 40, 1. Again, which is going to result into a matrix of dimension 1, 1. So finally, if you multiply multiply both these both these matrices, you are going to be you're going to be left out with a vector which is going to have a dimension of 1 cross 1. So this matrix multiplication is feasible. Now, before moving on to the matrix multiplication part, we should ensure that the x which we are passing into the weight function is going to have a feature containing all ones. So to do that, we are just stacking I'll show this in another cell. So np dot ones of 30 is going to generate a vector which is going to have 30 ones. But I think the shape of the x train is going to be 40. So this is going to be np dot ones of 40. Now, once you generate np dot ones of 40, we have to pass it into the h stack and stack it with the x train vector. That's what is being done over here. Yeah, I'll explain this in a separate cell. So one vector is going to be np dot ones of x train dot shape dot reshape of -1 to 1. So what this does is that np dot ones of x train dot shape of 0, the shape of 0 would be in this case 40, as it is having 40 rows. And then this vector is going to be generated, and then we are going to reshape the vector into the next format. Let me show you what's one vector. It's getting reshaped. And this is how it looks. It looks like a single column having like 40 rows into it. So once this is done, we are going to stack it with the x1 and then pass it to the function weights to find the weight. So here after finding the weights, we have to do the prediction. So the prediction formula for linear regression is x at w, right? Now we can use this to predict the y values. So it should be w transpose. Okay. Now if we predict, we'll get the y pred. And if we want to find the values, find the mean squared error, we can just say as it is returning np dot mean of y minus y pred the whole square. Now we can find the loss. Let's try printing how much loss did our regression model get. So this was the loss. So if you want to visualize our predictions, let's try visualizing it. And one second. Let me run the same code here with X train and Y train, and instead of this, it's going to be X train. Yeah. 2 lines are appearing. One second, I'll share it again. Is it visible now?
Yeah, it's
Yes.
Okay. So this is how the line finally looks like after plotting it. There was an error in the previous slide. It showed 2 lines. So if you do the same thing for the Y predict also, sorry, Y test also, you'll get this line finally. So let me see the doubts. Okay. So initially that previous collab had another cell running. So both the graphs has collapsed and 2 lines occurred simultaneously. So I just switched my another collab. Okay. So that was the error which I made. I think nothing else. So what, is there any doubts? One second. Yeah, I'll show the code again. Maybe I'll share the link to the collab in the group in this meet itself. Sarnath,
Yes.
is it okay if I share the link of the collab here?
Yeah, it
Or-
should be fine. Yeah.
Okay, so I'll share the link of the collab here. If you have any doubts, please post it in the discussion forum. We'll cover gradient descent in the next week. Okay. I think it's almost 7. This is the link to the collab. If you have any doubts, just ping me. Okay. So, can anyone explain how the values of X and Y are being stored? So here, which X and Y? Okay, this one. So here, I'm generating the values of X. Here, this is going to be a random number. I'm generating 50 random numbers, and then I'm multiplying it with 2. Then Y, the values of Y are going to be like just 3x plus 4. But with the 3x plus 4, I'm adding a random noise to make it like bit disfigured. Okay. I shared it in the same chat. Just check it. In this meeting chat, I've shared the link to the collab. Is it visible?
Not yet, ma'am. We have not
Not.
received it in the
One
chat.
second. Sorry.
No issues.
Everyone, yeah. Is it visible now?
Yes, ma'am. We got it.
Yeah. Try running this collab and there is gradient descent also at the end of the collab. Try doing it also. Anyways, we'll discuss it in the next session. Okay.
Sure, ma'am. Will do.
Any other doubts? Yeah, X and Y are arrays. Okay.
Ma'am,
X
it
and
is asking for access. Access
access.
denied. Yeah.
Okay, 1 second. I'll give the access. Now check.
Yes, ma'am. Now we are getting it.
Yeah. So we'll meet in the next session next week. Okay.
Sure, ma'am.
Bye.
Thank you so much.
Yeah. Thank you.
So I'll also share my collab here just for the.
Sure,
Yeah,
sure.
I'll just chat.
Yeah. Yeah. So
I'll
I think
stop.
so. You'll also get a mail hopefully. So by sharing. So I think so still. Right.
Yes, sir. We are able to view your collaboration. Yes.
Yeah. Sure. Okay. Fine. So
Thank you
we'll
so
meet.
much.
We'll meet the same time the next week. 6
Thank
o'clock.
you.
Thank you, sir. Thank you,
Yeah.
ma'am.
Thank you.
Thank you, sir.
என்னம்மா? யா- இல்ல இல்ல நீங்க வச்சுக்கோங்க. எனக்கு 100 ரூபா இருந்தா கொடுங்க. 500 ரூபா கொடுத்துருக்கேன். 453 ரூபா கொடுத்துருக்கேன். அதான் 100 ரூபா போதா? 500 4 இப்படி நானு 453 460 எடுத்துக்கோங்க. 40 இருக்கா? இல்ல அதை கொடுத்துட்டு 40 rupees இருந்தா கூட எக்ஸ்ட்ராவா உங்களுக்கு நான் 60 கொடுத்தேன். இல்ல இல்ல 453பா, நான் 460 இது பண்ணிருக்கேன். சரிங்களா, நீங்க 100 ரூபா 560 ரூபா கொடுத்துருக்கேன் நானு. எனக்கு 100 ரூபா கிடைக்கணும். ஆமா. சரி. எழுதுவீங்க. ஹலோ.